Let's talk about latitude and longitude. The Earth is divided in two halves. The top half is called the northern hemisphere, and the bottom half is called the southern hemisphere. The dividing line between the two hemispheres is called the equator, and we measure that as a 0-degree latitude. Let's apply that to a map. Here's a map of the world, and here's our equator. Our northern hemisphere sits on the top of the equator, and our southern hemisphere sits below the equator. Latitude is a measurement of how far north or south of the equator you are. Latitudes range from the equator, which is 0 degrees, to 90 degrees north, and from the equator to 90 degrees south. Latitude lines are horizontal, like the rungs of a ladder. Think of them as flat. I like to think of them as flatitude. Notice in this picture how the lines of latitude are parallel to one another. They are often called parallels for this reason. Here are important latitudes that you will need to know for the rest of the year. So the Earth can also be divided into left and right, or east and west halves. These halves are separated by a line called the prime meridian, which is measured as 0-degree longitude. Everything to the west of this line is known as the western hemisphere, while everything to the east is known as the eastern hemisphere. So on our map, this is our prime meridian, running straight down through Greenwich, England, not pictured, but that's usually how you can find it. This is the western hemisphere on the left, and this is the eastern hemisphere on the right. Always remember that North America and South America are western hemisphere continents. Okay? Longitude is a measurement of how far west or east you are of the prime meridian. Longitudes range from the prime meridian, which is 0 degrees, to 180 degrees west, and from the prime meridian to 180 degrees east. Longitude lines meet up at the north and south poles. Notice how the lines of longitude in this diagram are not parallel to one another. They are often called meridians. But also notice how they intersect at the North Pole. If we were looking at the South Pole, they would also intersect. And these are important longitudes to know for the rest of the year. Okay, so let's take a look at some reference table maps that relate to longitude and latitude. So this is a surface ocean currents map, and I want you to pay close attention to how it is organized. It's quickly overlooked, but notice it's not as it typically would appear. North America is not on your usual left side of the map. Right? North and South America are typically on your left side, which correlates to your western hemisphere. Now the hemispheres haven't switched, it's just the map is drawn differently. Here's the prime meridian that separates western and eastern hemispheres. And here's the international date line, which separates, again, what eastern and western hemispheres, but on the opposite side of the Earth. So it's looking at it from a different point of view. and one that's disorienting if you don't know about it in advance. Same thing with our plate tectonic map in our reference table. It also is sort of backwards. Again, here's our prime meridian, and here's our international dateline. So there has been some movement of what we typically would say, but this is still the Western Hemisphere, and now this is the Eastern Hemisphere. Okay? So the last map that we're going to look at is a generalized bedrock geology of New York State map. This map shows the bedrock and the time period in which that bedrock was formed across New York State, but it also shows the latitude and longitude across the state. So I want you to take a look at this area, and you can see there's a bunch of numbers, especially across Long Island. It's confusing, there's no doubt about it. I mean, this is a very hard map to read, so I'm going to highlight some portions for you so you can understand what I'm talking about. So here's 41 degrees north. I know it's not the straightest line, but you get what I mean. That's a line of latitude. The next line of latitude is here at 42 degrees north. And if you look very carefully, in between the two, there's a plus sign. And it's really not a plus sign, it's just a meeting point between a line of latitude and a line of longitude. No matter what, that plus sign in between these two latitude lines marks a halfway point. So how can we quantify that? What can we say? What can we say about that halfway point right there? Can we say it's just halfway between 41 and 42 degrees north? No, we have to do better than that. One way that we reference the halfway mark between degrees is by saying 41 degrees and 30 minutes. So the breakdown is 1 degree equals 60 minutes, and 60 minutes equals 60 seconds. And I'm not talking about time, I'm talking about a measurement scale when it comes to degrees. So it's just a breakdown of that unit. If I go further up, so there's my 43 degree north latitude line. If I went halfway between those two, somewhere over here, what do you think that would be? It would be 42 degrees and 30 minutes north. All right, let's take a look at longitude. Works the same exact way. So here's a line of longitude, 77 degrees west. Here's another line of longitude that's halfway between. That's 77 degrees and 30 degrees west. Then here we have 78 degrees west, followed by 79 degrees west, and in between those two we have 78 degrees and 30 minutes. Most confusing thing here is that as we go from this side of the map, the right side, to the left side, we're increasing in value, which is kind of opposite to what we think. Usually when we're moving across numbers, we're increasing numbers, but we're going to the right most of the time. Well, now we're going backwards and we're increasing numbers. So you just have to get used to what this map is showing and practice, and eventually you'll get the hang of it. Okay? So that's it for my part. I have a little video that I want you to watch that follows this. Enjoy. Thanks for watching.